Welcome to the IEEE Future Networks podcast series, an IEEE Future Directions digital studio production. In March, we convened 4 EDGE subject matter experts to discuss the EDGE ecosystem from now through 2030. Today, these experts will speak to the evolving EDGE automation platform and EDGE service platform frameworks. Our subject matter experts are with us today in the capacity as co-chairs of the EDGE Automation Platform Working Group of the Future Networks International Network Generations Roadmap. As well, Frederick Kautz is the head of EDGE infrastructure for DOC.ai. TK Lala is the founder of ZCureZ, a consulting company in edge computing and cybersecurity. Prakash Ramchandran is the founding director and secretary of the Open Technology Foundation, and Sujata Taibrala is the One API Worldwide Community Development Manager at Intel. To our panel today, thank you for sharing your time and expertise. Let's begin our conversation today by asking the question, how do 5G and follow-on next-generation networks, 6G and beyond, embolden and perhaps fertilize edge use cases?
Sure. Thank you very much for the question. What I see from the industry being part of the next generation roadmap, we see that there is a evolution of beyond 5G. At the level of 5G, we have release 15, release 16, now moving towards release 17 under the 3GPP. At the same time, we are seeing that networks throughputs are multiplying. Obviously, the 5G target against the 4G was 10x. So you see there is a lot of changes on the throughput side of it. But as far as edge is concerned, we are focused on the latency side of it, more latency as we call it, in terms of very similar to real estate, location. So we see that the 5G to 6G as well as WiGig and Wi-Fi 6 all are looking for first throughput followed by low latency or optimized latency, and then power consumption and energy saving and all that. Now, with respect to the next generation, obviously we see that in the context set that we have the edge automation platform, which was more underlay, more towards the resource platform to resource angle, we have moved to edge service platform. So our directional sense based on what is happening because of the volume of data that is going to be moving to the edge, we are seeing visionary that as we will have more to do with how do we get the access at the edge or access to the edge for the various data networks. So from the end to end, if you take, you got the because any edge is anywhere between the user device or the user themselves, whether they are in factory or whether they are in enterprise, to the core, and cloud is beyond the core in the data centers. So there is a requirement in 4G, we used to call it as local breakout. Instead of that, we need a edge user plane function. And that is based on the various access gateways. So you can have a WiGig gateway, Wi-Fi 6 gateway, or you have a access gateway that caters to E node B as well as G node B. So basically, E node and G node are the respective cell towers which come in between, and then you have the portion which we cover on the radio side, the front haul or a fixed network. We cover the fiber to the from home to the optical networks and fiber, etc. So essentially, there is a convergence of different access on one side, and there is a distribution of edge data centers, or the nano data centers, what we call, or micro to nano data centers, depending on the form factor and the location where they are. So obviously, we see that this edge use case requires the technology aspect to amplify, accelerate the computational factors to the proximity which DK mentioned of the processing where you want to consume it. And so what we see is it's all data driven. And if we have voice, we used to take voice and then just uh, for voice, peer to peer was good, and voice has disappeared into data now because everything is data now. So essentially, we'll have to look at what the stacks are now, how stacks are going to evolve, whether they are going to just be stuck at where they were, or how does it change. So from the 5G and beyond perspective, we see that native cloud native services, as you see in the cloud, is coming to the edge. And since it is coming to the edge, how do we slice and dice the various uh, networks to provide the radio slice, map it to the transport slice, and to the data network, which in this case, data network is local, which means it is at the edge, not at the cloud in the vicinity beyond the massive data center towards the nano or micro data center. How do we support these edge native services? So those are the various issues we see coming up as we move from the automation platform, which we consider Kubernetes orchestration as the key, followed by the edge service platform, where you have more to deal with the services, multi services. So it is multi service, multi tenant, multi application, and then obviously you also have multiple ways to handle the security and the encryption, authentication. So from all this, we see that service is the service platform, and its service platform, the framework which we are trying to build, is what we are moving towards.
Sure. Just to add to that, basically, I will just talk about briefly on the 6G portion as so we've already seen how the edge use cases are being fostered by the 5G, right? 5G, ultra low latency and higher bandwidth. So same thing continues on the 6G, and the 6G is going to bring in, for example, hundreds of gigahertz is the analog bandwidth, and which translates to the digital domain 1 terabits, or even closer to the 1 terabits per second, and so forth. It's not unthinkable, even though it's seems like quite a bit right now, but it is happening. And once that happens, and the latency also is at the same time going down further, so to the sub microsecond. If those are happening, then those are going to tremendously help the AI and ML portion of the edge intelligence, because the edge intelligence is going to be powered by the AI ML. And what that does is that you will have, even though we will have tiny ML or this small memory footprint in different platforms, which are ideal for the edge cases, they are going to be fostered much higher bandwidth to connect with each other and form a kind of a mesh network and so forth, and it scales well and provide the intelligence and the automation that is needed in the edge computing. So the AI and ML is a centerpiece of the edge computing, and it's going to be more and more so in the 6G and beyond domain. And the 6G with the ultra high latency, ultra high bandwidth rather, and very low latency would help tremendously these types of growth. And this will bring in the intelligent Internet of Things, and also the mobility software like the liquid software we are hearing about, that will flow from one device to the other. This is going to propel all these things and making this edge computing to be very compelling and very useful for the industries.
This next question is for Sujata. What is the impact of heterogeneous infrastructure innovation in industry? How do you characterize the impact of heterogeneous infrastructure innovation for edge platforms and services?
Yeah, so as we have been talking earlier, Edge Services has uh, multiple use cases and they work across diverse platforms. So heterogeneous computing becomes a key to support that. So the applications may need to sit on a micro data center or at the cloud or at the user device, and each of these devices will have a variety of hardware platforms that could be sitting on them. It could be CPUs, GPUs, FPGA, or any number of accelerators that are there in the market. So today, what happens is that if a developer is developing a code for CPU, there is a separate set of tools, libraries, languages that they use. Similar is case with the GPUs. And in some cases, these tools and libraries and languages are also vendor locked in, means and proprietary, means they are not open source. So there is a need in the industry to open this up so that a developer, when develops software for one set of hardware, it can be easily ported to another set of hardware and can also work on multiple different architecture. So you can think about code running on CPUs, GPUs, and FPGA at the same time. And there is industry initiative going on right now uh, based on SYCL called One API. It was launched last year. It is based on something called SYCL, which has been around for a while and has become a de facto standard for heterogeneous computing. Particularly, the FPGA developers find it easier to program using SYCL uh, programming paradigm versus the typical programming languages that they have been using, which has a huge learning curve. So what we see is that emergence of this sort of open standards, open source software that can run on multiple platforms at the same time will open up the edge ecosystem and will let the developers develop their application once and then not worry about which particular hardware it is going to run on. It is, of course, maybe there may be some hand optimization required, but at least the basic or the initial barrier to entry to code on a different platform is removed using this.
Uh, Thank you very much. And where Sujata left off on the uh, acceleration. So, one of the key factors we have been facing challenges on the platform side has been how do we enable the services to use the underlying capability of the hardware. So the acceleration that requires standardization because unless you have standards uh, to be able to use either for the platform or for the infrastructure, the services cannot exploit it. So standardization has been the key challenge for us in the uh, early last 2 years when we dealt with the VM, and this year we dealt with last year we dealt with the container, and this year we are moving above the platform to service. Standardization of both the infrastructure, platform to infrastructure, and service to platform. So, in that context, just to pick up one sample from acceleration, if you have the GPU, FPGAs, and all that, you need the labeling to be able to select and place the workloads. So, to place the workloads based on the label, the labels must be exposed so that we know that what node, what cluster is being offered to the service to be able to use them. So standardization on the platform side to the infrastructure side, fortunately, is at least resolved for us in terms Kubernetes has taken over as the key for container orchestration. Now, besides container, even it is being used for cloud control planes or edge control planes, whether you do it with any of the provider. All providers have some kind of a Kubernetes offering, whether it's a GKE or AWS has got AKE or Azure has something. So all cloud providers are providing the Kubernetes as a edge. So our platform standardization aspect has narrowed down in the footprint of micro data centers. In terms of nano data center standardization, yes, we do still have some gaps, but most of them are already covered by the Arduino and the embedded toolkits with the Pi and all that. So you do have some uh, hardware infrastructure and ability to use the various libraries to do the standardization for the platform. For the services, we are looking at the challenges. Yes, it doesn't mean that platform resolved, all the standardization is resolved. Still, there are uh, portability and interoperability, which was mentioned earlier by uh, Frederick, that still continues to be one of the challenges. From the other aspect, if I look at before I go to the other one, I would cover what I have to cover is Mano. That is, you find that management and network orchestration was one of the key factors. When we started on the edge, everybody thought that, oh, the HC, NFV, VNF architecture is a great architecture. Let's just use it everywhere. And that is how the MEC came into picture, the mobile edge computing or multi-axis edge computing, as they call it. Now, the multi-axis edge computing did not take off in the earlier stages when it was called mobile edge computing because of the platform issues. And that having been overcome now with Kubernetes, next is how does the telco operators use edges versus how the cloud operators use, because somebody has to provide that facility. And this is where the standard challenge we had in the Mano industry, which was OSS, BSS, and the CNTTs and all that TK mentioned, have not TK, the Frederick mentioned about the CNTT. They are still trying to standardize. The challenge has been how do containers be used in onboarding a particular service, and how do we use the slicing and segmentation, and how do we differentiate between underlay and overlay. So there are some challenges in the workload distribution, and so is also about the API management, where you have Kubernetes API along with the custom resource descriptor being used, because Kubernetes is so standard, everybody understands, and slowly it has seeped in everywhere. So you just want to use the Kubernetes standard for underlay and extend it. And to extend it, you need to have a custom resource descriptor which can be consumed by the service or the platform to be able to use that through the API gateway. So there are API gateway aspects, which is another challenge. But before I move on to that, networking is very important. Without networking, we cannot do anything. So I'll hand this over at this time to uh, Frederick to talk about the network mesh and the topology, etc., for the routing.
Fantastic. So when we look at networking on the edge, it's where we're seeing multiple things occur. So one is there's this trend towards network slicing. We're going to see network slicing make a very big play in areas where you have a very high density. So when you start to look at areas like you have a stadium and you need to ensure that certain devices always maintain their bandwidth, things like network slicing are fantastic for those type of use cases, leading into a edge data center that can then do the processing of video or other low latency workloads. when we start to look at the general use case, the network slicing portion requires interoperability with the service provider, and it does provide some form of rigidity there. And one area that we can use to relax some of those constraints and push them into the software stack is to start incorporating things such as service meshes. So service mesh ends up, there's two different layers that we want to focus on. So when you're in a cluster or you're operating within a small set of clusters, then you can establish a service mesh which will look at things like, what's the identity of the thing I need to connect to? So in other words, I need to connect to a database. How do I find where that database is? It controls things like policy. How do I tell it that these things are allowed to communicate? And we'll get more into security later on. Then we also have areas around control and automation of that control. And that control could be things like, I have a load balancer. How do I automate the connections coming in across multiple systems? Simultaneously, there's also a series of related things are going on at the lower level. So these previous ones were more L4, L7, think of it like TCP and HTTP or similar level of protocols. You also, the thing with these type of application service meshes is they make the assumption that the low-level connectivity already exists, and we cannot make this assumption, especially on the edge. So we're looking at things such as layer 2, layer 3 service meshes, which are capable of negotiating connections, such as what protocol should I use to establish a tunnel? What protocol should I use in order to establish, what type of things do I need to go through if I'm doing something like service function chaining? Like maybe I need to go through a certain set of firewalls, through a certain set of intrusion detection systems, and a specific VPN gateway and concentrator. So these type of things need to be defined in a declarative way and allow the system to consume those specifications and then render them based upon the infrastructure that's underneath of them. And this creates a very nice layer of abstractions, because that means you have the L2, L3 concerns that are cleanly taken care of. Layered on top of it are your L4 and L7 networking concerns. And they're able to, in the same way that when we look at the OSI model with standard applications, that same model serves us very well in separating out the concerns based upon what is necessary for the operators of the clusters to provide versus what are the application requirements that you really need to have the application DevOps and developers jump into in order to ensure that their needs are being met, and creates a very nice demarcation point between the two of them.
So here's a question for the panel. What are some of the key trends and challenges for complex edge security in this context?
So this is TK. I'll start with this one, and then I'll ask Frederick to join me later on to add to that. So I think by now we got the kind of realization that the edge computing does help in significant manner for many of our applications and services. But at the same time, it does brings quite a bit of complexity on the security side of it, how to manage the security in this context. Now, one thing we all realize, and we should keep it in mind, as the information that we are trying to keep it closer to the generation and the utilization, meaning keeping it closer to the proximity where it actually originates and also being consumed, it helps in terms of the security and the privacy to be more robust by reducing, obviously, the attack surface that is exposed for the pertinent information. So the information doesn't get exposed unnecessarily to some of the other surfaces that it needs to travel through in a more traditional infrastructure. In the edge computing infrastructure, it helps many of the information to be contained or confined into a closer proximity, and thus it's a very positive thing in that sense. However, there is a lot of other issues that it brings in, the challenges. And first, also, I wanted to mention that the lightweight and the distributed security mechanism designs are very critical to ensure the user authentication, access control, model and data integrity, and mutual platform verification for edge intelligence. These are extremely important, and lightweight is a key, and distributed model is another key aspects of the edge computing, and security has to work with this infrastructure. Now, trusting the network topologies for the edge intelligence service delivery, when considering the coexistence of the trusted edge nodes and the malicious ones that exist, we have to be able to manage the trust where you have trusted nodes and we could have some malicious node scattered around. And how do you maintain the operations of the trusted nodes smoothly without being affected by the malicious ones that will try to infiltrate that? Now, edge intelligence plays a very key role in that part of the identification. The third part of this is the privacy. The privacy usually is referred from the personally identified information, PI. And we have seen verticals have different roles for this preserving their privacy. For example, HIPAA is in the medical industry. It's almost like a Bible. You can't deal with any of the information in the medical unless you maintain that amount of privacy as governed by the HIPAA. And that may not even go far enough, and it might be even getting more stronger. In general, there is something like GDPR, which is European SAP, and very similar ones we have in California and also nationwide in many other states we have. So privacy is definitely a more and more dominant factor that we have to maintain within our edge computing. Now, again, being in the proximity, keeping it within the origination and the consumption for this information helps significantly, but that doesn't necessarily completely solve the problem, because many of this information needs to travel even farther than just the edge node, even though they are being consumed there, but it probably needs help, or it needs to have some meta information that needs to travel somewhere else and then get also the reception. So anonymity, immutability, non-repudiation, and using the PKI and those things, these functions are going to play a significant role. Ultra secure, and in the defense industry, what we've seen is that the cross-domain guard, and there are different classes of information that needs to be maintained. So even though within the proximity, you have multiple level of users, and because of the multiple level of users and their roles and their access capability, you have to maintain those domains that are separated from each other. You cannot have one information mixed with another. And so in order to maintain those things, typically the industry uses cross-domain guard and some sort of a filtration systems. And these things will become much more sophisticated, powered by the AI ML, and will help this growth. Securing APIs, virtualized domains, devices along with the IoT sensors. These are some of the key things also going to happen. We also are seeing most likely there is going to be software type of SIM card that are going to be used, especially in the 6G and beyond. And we also, one other thing that we have to mention here is in the light of the network slicing, which is going to be dominant in the next generation network, we're going to see tailored and dynamically configurable, adaptable security, I call it, that will adapt with the intelligence, okay, again, powered by the intelligence to the context. So in other words, you don't need one level of security for all applications or all use cases or all or network slices. There is going to be a basic infrastructure in that security. However, there is going to be a programmable portion or adaptable portion and configurable portion. And ideally, it is going to be dynamically configured. So human doesn't have to go in there and start to manipulate those things. These are going to be done through the machine learning and artificial intelligence to power that, to make it suitable for the context. So beyond this, there is, and I think Frederick also mentioned earlier about the service mesh that is going to be, that needs to be protected. No question about it. Container protections is needed and all this. So the use case and the context awareness and cognition security are going to be the key. Now, real-time transparencies of the security is extremely important. There's another big can of worm, and I don't want to go into too much into it, but it's called post-quantum computing security. That's going to be, right now, most people use a symmetric cryptography. There's going to be an asymmetric cryptography that we started to see that also going to be playing a big role in that post-quantum edge for the security, because the security is going to be turned upside down with that kind of technology, and we need to be prepared for that as well. Blockchain is going to play some role, and identity and access management is a big issue. And I'm going to let Frederick expand on some of this, on the identity access management especially. Frederick, if you like.
So when it comes to identity and security, there is a new set of patterns that we're going to see as these technologies continue to progress. The original patterns are based on the assumption of very well-defined perimeters. We had originally on-premise perimeters. We extended that perimeter to the cloud, and we established a fantastic set of perimeter defense through firewalls, through other similar types of defense mechanisms in order to protect the applications and the networks that they sit on top of. As we proceed into edge computing and we start to see 5G start to take off, 6G in the future, and we start to see much more IoT in our environments, the set of assumptions that we relied upon no longer are no longer as valid as they once were. And this gap that presents itself as an opportunity for attackers to make use of in order to break into these systems. So our assumptions have to change so that we can defend these systems properly. One of the key assumptions that we need to change is how we look at things like identity. So instead of saying the network is the thing that we trust, instead, we're going to move towards a workload is the thing that we need to defend. The resource is the thing we need to defend. The user is the thing we need to defend. And so that we can give each of them cryptographic identities, and then we can use those cryptographic identities to create policy that defines the interactions between them. And these policies are not based upon the network, though you may include the network as part of the attestation process. But instead, you have this fundamental thing that you can defend, and that workload is able to then establish its connection with other systems and have verifiable proof that it is who it says that it is, both for what it's connecting to and the information that it presents to others as well. So this has other implications on the infrastructure as well, because things like access control list, which originally your IP and port combinations was your identity, now you shift that over to this cryptographic identity, which then frees you up to re-IP or reconfigure your network, relocate the workloads to places where they need to be. And it also has a very nice tie-in with additional types of workload environments that we're going to see come along in the near future, such as secure enclaves, where we can have a remote attestation with a cryptographic identity within it that it can then use to identify itself to the outside world, even in a more hostile environment. And some of the protocols that we see that are coming up to help along these are things, and they're not the only ones, but we're seeing things within the CNCF. We're seeing the SPIFFE protocol with the Spire reference implementation. That's spelled SPIFFE. We're also seeing things like Open Policy Agent come along, which is providing a language for how do you declaratively define these types of interactions. And we're seeing these things get added across different parts of the infrastructure, ranging from the application at the L7 layer down to the things that control the L2 and L3 layers. In short, what we're seeing is a move towards what's being referred to as a zero trust security model, where you constantly validate and verify the workloads and the connections that are attached to them. And we believe this is going to be a fundamental shift in how security is handled in the future, not only in the service provider level, but also in the enterprise application level.
Okay, let's now talk with Sujata about where people who are listening to this podcast can go if they are interested in getting more information or if they would like to become involved in this Edge Automation Working Group.
So anyone listening, please go to the INGR website. We will be providing the link on the description below. On the INGR website, you can find information about our working group, which is the EAP working group or Edge Automation Platform working group. Our roadmap for previous year is already published there, and the roadmap for this year is going to be published shortly. So please stay tuned for that. As far as participating and contributing to this working group, we welcome you here. We value all sort of different diverse voices. So we'll be happy to get you become part of this group. There is an email address that you can send an email to if you wanted to be part of this group, and that email also will be included in the description below. Thank you. So looking forward to talking to you as part of this group. If not, I hope that you find some value in reading our roadmap and from the podcast today. Thank you.
Thank you for listening to this edition of the IEEE Future Networks podcast with the experts. Discover more about the IEEE Future Networks initiative and inquire about participating in this effort by visiting our web portal at futurenetworks.ieee.org.